Okay, let's talk about similarity for area and volume. Now, let's go back to our little cubes where we began and we started. This guy, little cube, we're going to go 1 unit by 1 unit by 1 unit. In this case, it is clear to see that this cube and this is a cube as well. And I will show it to you because it is 2 by 2 by 2 by 2. So we got a cube here and a cube here. In this case, we want the length. The length of this cube is 1 unit. The length of the other one is 2 units. So we'll call them A and B. So I have the length of the first unit, A, is 1 unit by and 1 unit. The length of the other one is 2. Now, let's talk about area. The length of 1 gives an area of 1 times 1, and so the area is 1 unit squared for part A. But for component B, we have 2 by 2, and it's very clear to see we have 1, 2, 3, 4 for its area. So we end up with 4 units squared. Over here for volume, if I take a look at volume, I have 1 by 1 by 1. And so I have 1 unit cubed. Over here, I have 2 by 2 by 2. And in this case, that would give me 8 units cubed. Now, just in case you don't believe me, let's take a look. We have 1, 2, 3, 4, 5, 6, 7, 8. 8 units that made up that cube. So if we reassemble, we have 8. There you go. And so hopefully that makes sense. Now, what if I have item C? And item C has a length of X. If item C is similar, meaning has the same shape, not necessarily the same size, if it is similar to both A and B, because we knew A and B were both cubes, we said that from here to here we squared, and from here to here we cubed. Did it make sense that it still worked? Here is 2. 2 squared is 4, and 2 cubed is 8. Our generalization says that if these figures are all similar, that their lengths might be a ratio of 1 to 2 to x. Here they're going to be 1 to 4 to x squared. And here they're going to be 1 to 8 to x cubed. And so we would have the volume of our cube with unknown side. If I have another figure D, where it is of r size, we would therefore have r squared for its area and r cubed for its volume. I would simply add another term on here. But if I subtract off the A and the B, I no longer need them. What I end up with is a rule. And that rule says for length of two similar figures, x to r is the ratio. But for area, x squared to r squared is the area, length and then area. And then x cubed to r cubed is going to be the ratios of their volumes. And it's going to work that way every single time. Regardless of the shape, regardless whether it's a cube or not, these are going to be true where you have length, area, and volume. So there you go.